So hello everyone and welcome to our professional learning coding series. My name is Nina Nesseth and I'm a staff scientist at Science North. Today we're going to be going through a grade 7-8 lesson with ties to our new coding curriculum as well as some cross-curricular connections. Before we begin today, I would just like to welcome us all with a land of acknowledgement. We would like to acknowledge that we are on the traditional and ancestral lands of the Atikameksheng, Anishinaabeg, and Wahnapitae First Nations. We would also like to acknowledge the Métis Nation for their cultural and economic contribution in this area. These lands sit in the Robinson-Huron Treaty area, and as we are all treaty people, it is important to us all, for us all to be thinking about what treaty area we live in and are an active part. So let's take a moment to appreciate the land that we are on by acknowledging the traditional territory and treaty area that you are located in. And as well, before I move on with some housekeeping, I just want to welcome behind the scenes, I have my colleague, Jose. Hi, Jose.
Hello.
So Jose will be overseeing our chat today. So if any point during our session you have any questions at all, please, we invite you to type your questions into the chat and Jose will answer you as they come up. And as well during our session, if we have any relevant links that you will need, Jose will be dropping those into the live chat as well. So thanks, Jose. So as well, before we begin, I just wanted to point everyone in the direction of some school resources, teacher resources that we have right now. So of course, Science North is offering virtual learning packages that will support your teaching in your classrooms. And as well, we do have a series known as the Science at Home lesson plan series, which is a resource that you can find on the Science North website. And that resource includes, here, I just changed to our schools.sciencenorth.ca/justteachers, and the link to Science at Home is just in the sidebar here. And those are lesson plan resources for K-8 science curriculum that are specifically written with synchronous learning in mind. So these are all activities with full lesson plans that you can engage your students with through virtual learning that use hands-on materials that your students will be able to access easily within their own households. As well, we have our professional learning series and many other resources for teachers that you can find at education.sciencenorth.ca. At that website, you can see the center banner here includes our professional learning coding series, and that will have all of our resources for our session today, which includes our lesson plans, handouts, as well as recordings for our live video sessions. So if you're joining us late today, or if you want to revisit any of the content from our videos for today or tomorrow, or from past sessions that we've done, all of those resources live on this education.sciencenorth.ca website, and they're free for you to download and free for you to access even after this, this workshop series is ended. So for this particular session, we're going to be looking at our lesson across 2 days. So we have a part 1 and a part 2. Today is our part 1, where we're going to be looking at introducing our concepts for this lesson, and we're going to be applying it through an unplugged classroom activity that will set the foundation for tomorrow. And tomorrow we're going to be building a program in Scratch and going through different opportunities for extension and ways to tie back the coding lesson to curriculum, math curriculum, and science curriculum links. Of course, in terms of math curriculum links for grades 7 and 8, we're going to be tying very, very closely to our new algebra coding curriculum. This lesson in particular will also tie into some of our foundational probability pieces. In particular, we're going to be looking at independent and dependent events. And then in terms of science curriculum, I am going to be linking the coding content to grade 7-8 interactions in the environment. just to demonstrate a way that we can take coding concepts and connect them cross-curricularly in order to sort of bring sort of different content connections to our students. So to jump right in, just in terms of laying the foundation with independent versus dependent events. When we talk about probabilities and independent and dependent events, we tend to use this classic example where we have two events. For example, in this top image here, we have our first event being that we pick a random card from a deck of cards. And in this case, that random card is a 6 of hearts. Now, if I take that 6 of hearts and I remove it from the deck, I now have one fewer card in my deck. And so, of course, that changes the probability of picking a specific other card from my deck. So the probability of picking this 2 of spades has now been affected by the act of removing that first card from the deck. So these two, we would know, are dependent events because the outcome of one event affects the outcome of another. And then on the other side of things, we can see two other types of events in our classic example, which is, picking a card from a deck and rolling a die to see what number pip kind of shows up. So no matter what card I remove from my deck and how many I kind of remove from my deck, it will not have an impact on the probability of rolling, say, a 1 on my die, because those two events, the outcome of one does not affect the outcome of the other. So those would be our independent events. So let's connect the idea of dependent and independent events to conditional statements in coding. Dependent events especially are a great connection point for describing conditional statements, because this conditional statement is an expression in code that describes an outcome if a specific condition is met. And we usually frame conditional statements as expressions built around the statements if and then. So if a condition is met, then we'll have a specific outcome. Sounds a lot like how we know dependent events are related to each other. So if I go back to our cards example, if I draw my 6 of hearts and remove it from the deck, then I have changed the probability of selecting this 2 of spades from my deck. So I have my cause and my effect. To take now an example from interactions in the environment, so I'll take a very simplified example of an interaction. We can have our condition, so our question that we're answering. And the question will be, are there moths available in this environment? So are there moths in this environment? And so when we ask that question, the answer can either be, is it true? Yes, there are moths, or is it false? There are no moths. So that's our condition. So if our condition is true, if yes, there are moths, then our outcome is that the bats in this environment can eat the moths. And then if our condition is false, so our other possible outcome, so if false, there are no moths, then our outcome is that our bats have no moths to consume. And so you can kind of see here how we have dependent events, moths being present and bats eating moths, and how we can describe them using conditional statements. This second condition here that we have here describing if the condition is false is often in code also described as an else statement. So else is sort of a catch-all expression that will capture any other outcome or any other condition other than this true condition. So if we look at it a different way, if moths are present, then our bats can eat. Else, which we can kind of like think in our brains of as being equivalent to otherwise, else our bats cannot eat the moths. And this brings us to our unplugged classroom activity. This is a way for us to dig a little bit deeper into exploring those independent and dependent relationships in terms of interactions in the environment, and then get some practice as describing those relationships using conditional expressions. So ideally, this activity would be delivered, in non-pandemic times with all of our students sitting in a circle in a classroom. So I am going to describe this activity in its sort of ideal environment first, and then afterwards we'll address how this activity can be approached either through physically distanced learning or through synchronous learning, because this is an activity that I hope that you would be able to take with you and use once we've reopened and once we're no longer having to worry about synchronous learning or physical distancing. So in our ideal situation, we would have our students seated in a circle, and we would be assigning each one of our students as either an abiotic or an abiotic factor in the environment. So of course, our abiotic factors are our non-living factors such as air, water, soil, temperature, and our biotic factors are any living organisms in our ecosystem. Handily, in our lesson plan for this lesson, I've included a list of 35 biotic and abiotic factors, so you don't have to worry about generating a list. So we have 35 that you can just assign to students, and students can take some time to create a label or name tag for themselves so other students can see which factor they've been assigned. And there's also a handout included that asks students to spend some time reflecting on their factor and describing it as abiotic or biotic, and just a little bit more information about whether that factor is a consumer or producer, etc. For the assignment, the only tool otherwise that we would want to use is some form of string or rope or twine. It can be in a large spool, or it can be in pieces, as long as those pieces are long enough to be able to go across the full diameter of our classroom circle. So for the activity, we would start with, I like to start with the student who's assigned air, and you would pass the spool to that student and ask them to describe, look around the circle, look around at the other students, and choose one other student and describe the interaction or the relationship between those two factors. So for example, our student who is air might say that they have a relationship with, or they have a connection to the mouse factor, because mice need air to breathe and to survive. And so holding on to one end of the string, they would then pass the spool to that student. And now our student who is the mouse would have to look around and select another student who then would have an interaction as well. So that mouse might say that they have an interaction with grass, because mice use grass as camouflage or to build their nests. Now, a few things to keep in mind as we continue building these connections is that repeats are encouraged. There's no rule against having the string only touching one factor at a time. We want to pass the string all around the circle as many times as we can, and it'll mean multiple connections to the same elements. And also, as a teacher who's facilitating this experience, students will find some really obvious connections, especially in terms of consumption, which is great. But you may have to do a little bit of prompting to have students think a little bit more creatively about how different factors are interrelated. But this can continue for 5-10 minutes or until you run out of string, making sure that every student has at least one connection and try and exhaust sort of possibilities. And once we've done that, we can ask students to describe their observations about this web. So so to describe what sort of relationships or observations they make about these connections. So they may notice, for example, that all of our biotic factors pretty much without exception, need air and water to survive. So there should be lots and lots of connections to air and water as abiotic factors. They may also observe that producers, for example, tend to have more connections than a consumer, like our bear. And so kind of looking at those different connections that way. And then to move on to relating this to our conditional expressions and our dependent and independent events, we would seek now to identify independent and dependent relationships within this web of activity of interactions. So for example, I've highlighted two separate events. You would ask your students to choose any two connections that they observe. So select a student and they may say bear eats salmon as one of the connections, and mouse uses grass to build nests. Now, are those two interactions here, and I've just highlighted them so that we can see them better, are these two interactions independent or dependent events? Now, you can sort of actually see it as a visual representation here, but students should evaluate sort of the events and their outcomes and notice that these are independent events, because whether a bear can catch salmon or not has no impact, at least no direct impact that we can measure or observe on this web, to whether a mouse has access to grass to build a nest. And vice versa, a mouse using grass shouldn't have any effect on a bear's ability to catch a salmon. Now, to use another example, a student may choose to highlight, or you can prompt to your students to select the events yourself. Sunlight helps birch trees to produce nutrients to grow. So birch trees need sunlight to grow, and deer eat birch bark. So in this case, you can actually see that there is a visible connection between these two events that hinge around our birch tree. And in fact, these two events are dependent, because if our birch tree is unable to grow, if it has, say, for example, limited access to sunlight to produce nutrients to grow, then our deer will not be able to eat birch bark off that tree. Our handout sheets that are included with this lesson plan include exercises for your students to then pull interactions that they've observed from this activity and describe them using conditional statements, both with if-then formats and if-then-else formats. So for example, if we return to our bear eating salmon example, we can say that our condition is there salmon available? If there is salmon available, then our condition is true. And if our condition is true, then our bear can eat. It will be consuming the salmon. And to take this one step further, to include our other condition, so if this condition of salmon being present is not met, we will add our else statement. So if our salmon is present, then our bear can eat. And else, so if our condition is not met and salmon are not present, then our bear has no salmon to eat and is unable to consume salmon. And you can ask students to describe these impacts in more detail. The exercise here, the goal of this exercise isn't to dig too deeply into these relationships. You may want to do that if you are exploring this unit with your students, especially if you're working with your grade 7 students. However, if the goal is just to describe dependent events in terms of conditional statements, which is my goal here, then we don't have to dig too deep into the content. So in terms of what we are doing tomorrow and building off of our activity today, with tomorrow's activity, we are going to be taking this foundational knowledge about conditions and about how affecting the values of these inputs affects the outcomes in environments to create a simulated, a very simplified simulated ecosystem in Scratch. And this is going to be a really great activity for your students to use functions and to use special elements in Scratch that allow you to call upon functions in different orders. And it will allow your students as well to manipulate values and measure outcomes. And I'll be talking tomorrow as well about how we can link back the application that they'll be making to graphical elements in their math curriculum as well. So for tomorrow, we are going to be working in Scratch, which if you haven't worked in Scratch before, it is a free application that is super versatile and very easy to create sort of different experiences for your students and sort of scale your experience, scale the experience within the application for students at different levels of coding. You do not need an account to participate in tomorrow's activity. Though for teaching in your classroom, you may wish to create an account or have your students create free accounts to be able to save their data. But for us tomorrow, you will not need to create an account. We'll just be providing you with a link so that you can access the application and follow along. This is a shorter lesson that we went through today. And I hope that it was a really clear way to illustrate that making connections between coding fundamentals and what you're already teaching in your classroom, whether in the math curriculum or in the science curriculum, it doesn't have to be a huge, complex challenge. We can find really easy ways to find connections between a fundamental coding concepts, such as conditional statements, and apply them to something that's maybe a bit more tangible to your students. If at any point you have any questions about how you can do this with other areas of your curriculum and connecting them back to coding, feel free to reach out to us at educators@sciencenorth.ca. We're here to answer any of your questions about the lesson plans that you are watching here online, live, or any of the materials that you're visiting through our Science North resources. As well, we are here to answer any other questions that you may have. For example, if you are brand new to coding and haven't used these tools before, we can have one-on-one sessions with you to get you started and having you feel more familiar and comfortable with the tools. And if you are already more familiar with these tools, you can still contact us with questions on how you can sort of plus up or modify your teachings to bring in new experiences to engage your students with these coding tools. We're happy to help, so feel free to reach out to us at this email address. As well, we have a survey that, before I continue and talk about the survey, I just saw a question that came in to repeat the last if-then-else relationship with the bear. So I will go back and do that because we have the time to do it. So just to track back to the logic of if-then statements and if-then-else statements. So just to go over one more time, think of it in terms of like cause and effect. So with our if-then, our if is just setting our condition. So our if is asking the question, is there salmon available? So if yes, salmon is available, then we have our outcome. So if there's salmon available, our outcome is that our bear has salmon to eat. When we add else to our conditional expression, it's capturing those other possible outcomes. So with if then else, if there's salmon available, then our bear gets to eat. Our other outcome, our other possible outcome is that if there is no salmon available, so that's if the answer to our question of is there salmon available, if the answer to that question is no, then we get our other outcome, which is there is no fish available, which I just chose to represent with a bear that's still hunting. So Michael has a great comment that says flowcharting based on logic that is limited to dual answer only conditions is a missing skill. Has flowcharting disappeared from code training? It hasn't disappeared from code training, and actually you can choose to incorporate that into this lesson too, especially if you're drawing these relationships. And so that was kind of a little bit more similar to that first example that I demonstrated with, if I just go back many slides to our, how we sort of described the same sort of situation using if-then statements and our moths and our bats, which had the same sort of relationship. You can see how I've sort of drawn this more in a flowchart style, not exactly in like the traditional flow charting that you would see from code training, but basically in that similar respect where you can actually draw the paths for your different conditions. And so if that's a way that you would like your students to go through and actually visualize the relationships or visualize the outcomes, especially if there are only two outcomes, that is something that's already useful for probability and exploring dependent events and independent events in math curriculum. And the same applies for exploring and describing events through conditional statements. So thank you, Michael, for bringing that up. Absolutely. Flowcharting is a great visual way for your students to be able to describe those statements. Let's move back to my survey slide. Thank you for those great engagements. And just to add to what Michael has also added, so everyone else who sees this video in the future also sees, flowcharting is certainly helpful for people when they're working through Scratch and helps with debugging, because it helps you see the flow of your algorithm, so your program and the different steps that they're achieving. It is a great part of the planning process, and I can certainly, if anyone has more questions about how we can incorporate flowcharting into this learning process, feel free to reach out to educators@sciencenorth.ca, and we'll be able to set you up with some tools to be able to include flowcharting as a visual aid for students, because it is absolutely a great way to break down the steps and to be able to follow the different paths that your code will take based on whether one outcome is met or not, or one condition is met or not, and what sort of outcomes you receive from those. Scratch is an interesting example in that case of looking at that flow charting, though, because the blocks don't visually, it takes a little bit of a jump to go from flow charting to visualizing the blocks, but absolutely it is a really, really good tool to get students familiar with how conditional statements work. I'll just take a moment to allow anyone to add any additional questions or comments before we go today. There is a survey that is included in this link on screen if you're using an RFID scanner. As well, we are sending our survey link to your email addresses that you used to sign up for this workshop today. And finally, it should also be dropping into the chat. Your feedback is important to us. It allows us to know what is meeting your needs in our workshops and what we can include in future to be able to better meet your needs. And there's the link there. Thanks, Jose. And so by giving us your feedback, it's a gift to us to be able to help provide you with additional resources. So thank you very much for joining us today, and I look forward to seeing you tomorrow for part 2, where we're going to be looking at Scratch to build our program. I hope everyone has a great day.